I was just trying to get the downloads. I forgot where Chrome puts downloads. I just downloaded them all. But how do you find that?
Well, wasn't there a thing here that you could view in Finder or whatever it's called?
There was. Do you remember what that was? How we got that?
No. I think when you download
Here,
one,
maybe here, files. So it's this zip.
Oh, I see. You put them all in.
I'll use the default. So, okay.
Excellent. So we could just go through them.
Yeah. And then once we're through, we'll probably have to go and get the one that we missed.
Yes. Okay, so I'm just going to go through these in the order that they happen to get downloaded here. So the first one is the floor is DNS. So will somebody come up from the floor is DNS and give your presentation? Excuse me? Okay. We'll do you later. That's not a problem. Not a problem. We'll do you later. Okay. So let's go with the next one. Spin dump. Yeah, it's quite the maze to get up here. After he's done, I'll try to give the next person a cue to move your way to the front of the room before you, so we don't take as much time. All right, so just use the left and right keys too.
Okay, so here's the presentation of the quick measurements table and our project we call Spin Dump. So we've been working for a couple of IETFs on this Spin Dump tool. It's a network latency measurement tool, basically, that looks at quick and other protocols. Today, we had some ideas of implementing some experimental proposals for measuring packet loss. So there are a few different proposals out on using some of the reserved bits in the short header of the quick packets. So we needed also to create some sort of unified handling of quick versions, because we now start to see a lot of different versions and different uses of these experimental bits. And yeah, that's basically what we tried to do. And what got done was that we made a table-driven version of experimental and non-experimental quick versions. We implemented 2 drafts of these loss measurement bits, and we are currently developing sort of reporting of loss measurement events in our tool. We're also integrating this into some testing environments, using it, for instance, a Mininet test VM that we can use to test a lot of different network scenarios, basically. We also did a bunch of bug fixes. This is a list of how we are handling different quick versions. So previously, we had kind of nasty structures where different behaviors based on different quick versions, basically, we had to go into every function and check which version it is. Now we have generalized this quite nicely so that we can add new experimental versions with new support for different header formats, etc. And yeah, make it much more dynamic and nice. And yeah, left and right. So some of the loss detection proposals that got implemented was one that is based on these Q&R bits that will be presented at MapRG. So we have that implemented, and we also have this round-trip loss measurements as well. So we have a bunch of proposals in there. What did we learn was that supporting all quick versions is quite demanding. It's quite demanding especially when we have a protocol that's evolving and we have a lot of experimental proposals, to have a nice structure of handling, you know, all of these different cases. We see that both these loss detection proposals have measurements in real networks, and we hope to be able to facilitate more measurements of this. But yeah, problem is that we only have 2 reserved bits, and 2 reserved bits for 2 proposals is quite not that much. So this was done with me, Mark Zillar, Jari Arko, Sylvester, Fabio Mauro, and Alexandre. You can find our tool, the spin dump, at GitHub, and the new measurements proposals you can find at these links. So yeah, that's it.
Okay, thanks. Let's go on to the Okay, PTP notifications is next, and kickoff, nope, sorry. IOAM, make your way to the front so we don't waste time. Okay, use the right and left buttons. To
Okay. Hi, my name is Sachin.
Please use the microphone.
Okay. Hi, my name is Sachin Vishwarupe. I'm from Cisco System, and myself and Ufaz, we worked on the PTP notification. I am for the first time for IETF. As you can see, I have not used the format, and maybe next time we'll follow the same thing. So essentially in Cisco, I work on IP fabric. As some of you may or may not be aware, but these days the paradigm on the media also is changing. It's moving away from the standard SDI to IP-based fabrics, and that's what we work on. One of the key things there is the PTP, is the synchronization between your media gateways, endpoints, as well as the video audio sync is very critical, and the accuracy needs to be less than 500 nanosecond, and that's the reason we use PTP. With the PTP today, we actually have, as I noticed, we have the standard for the YANG already defined, like RFC 8575. But what is more critical for us is to get the notification, and that's because of the number of syncs which are involved in the PTP. In the PTP, like in the precision time protocol, in a second we typically sync 8 times. So we cannot expect network management system to sync and find out the deviation from those samples, because if you think about one day for a single switch, we generate around 700,000 sample points, and so we want to do it in a distributed fashion. So what we are thinking is to extend what we have it today with the PTP YANG to introduce like a new notification there. Okay, this slide again talks about the synchronization. I mean, earlier when we started on the audio video, right, if you are using a lower signal, or maybe think about like Ultra HD, HD, 4K, 8K, now the buffer cannot be that big, right? So that's the reason synchronization is critical. I put some more things, but more importantly, you can think like audio and video need to be in sync, and that's what we have been working on. So these are the use cases, what we wanted to address it in the hackathon. So essentially for the live event, we wanted to monitor via notification. Again, depending upon the media profile, the duration and the state, all those parameters need to vary, and that's the reason we wanted to do the configuration as well as generate the notification. Sure. So in the hackathon, we have the deliverables. We defined today like a PTP YANG notification model. Again, we need to review with the team. We develop a third-party application on Cisco switch. So the real deliverable here was a Python script, which will consume on the switch and push it as a YANG notification to the existing product. We have like a network management solution, and we extended that to introduce a new REST API to consume that notification and overlay the PTP information on top. So I mean, it's kind of eye chart, but I'm sharing the slide so you can see the example payload as well as notification. And this is how the user interface looks like. Here, what you are seeing is a spine leaf topology with Cisco switches, and based upon the PTP offset threshold, the switches at the runtime are color coded. So based on the notification, which WebSocket, it dynamically updates the screen. So based on the number of sample which has deviated, we actually color code those. And this was just the idea just to demo that part. And this is the backend where we introduced like a new application on the backend with the Python script, which completely integrates with the Cisco CLI. So it's as if like a original part of the Cisco, it's coming from Cisco, and you can monitor and control the notification part of it. So that was the idea. The whole idea is to take the notification and integrate into the PTP. Thank you.
Okay, IOAM is up and ILNP is on deck. Use the left and right buttons.
So this was a project to do IOAM, which is in situ OAM, operations and management. Basic idea, if you're not familiar, is to have an IPv6 extension header, hop-by-hop option that contains an IOAM option, which is information that the router fills in as the packet goes along its path. So the idea is we're taking metrics and performance measurements from routers in a path. So the goal we had today and yesterday was to implement something and show some interoperability. There's a couple of drafts on the IOAM. One is on the specific option, one is on the data format. And what we did, we brought up UDP ping, just a little program to do a UDP ping that sets the extension header and the IOAM option. And we had a client server, one router, and we were able to follow the path and have the information filled in. The kernel implementation or the router was provided by Justin. That's at this GitHub. And separately, the client and the server code was a different implementation. All of these were on Linux. Hopefully next IETF hackathon, we'll have some more router host implementations join in. So the way this works, for what we did, we ping a remote host, add a few options, and as you can see, we got some response back, and we parsed the IOAM message that we got back, and sure enough, the router filled it in. So more interestingly is the node information. This is directly from the IOAM draft, various pieces of information. So I have the egress interface, ingress interface, timestamps, transit delay, things like that. So there's quite a bit of information that we could potentially gather from the network in this fashion. So we did learn a few things, particularly trying to get things to interoperate. Getting the lengths right when we're parsing fields, particularly fields that hold lengths that correlate to other lengths. That was kind of interesting. Bit fields don't make things easier in this regard, especially when they're split across byte boundaries. And we also have a few suggestions to IPPM, particularly in some of the data formatting, opaque data format, for instance. It's a lot easier to deal with fixed fields than variable length data in this regard. So we probably have some good feedback on that. Wrapping it up, so we had a good number of team members and a couple of first-timers at IETF Hackathon. Thank you.
Okay, ILNP is up and TAPS is on deck.
Okay, so just some background information on ILNP. We had the first demo of what will eventually be a public release of the code at the last IETF, and we've just been developing that, especially trying to fix some bugs that we found in at IETF104, which was very useful to know about. So the plan here was really to make sure that ILNP could work over a real network. That's the idea eventually. And so what we had was a network that consisted of some low-end routers but they are just commercial routers. They run IPv6 only. The idea is that ILNP works completely end to end. So the core routers just think you're running IPv6, whereas actually you're running ILNP. And the other thing that came through a fortuitous conversation with Stefan Bortsmeyer was some DNS improvements that help with DNS in general. And I'll say a little bit more about those in a slide coming up. So these are the key things that we managed to work out today. We did some test runs with TCP over ILNP running over these commercial routers between two boxes that were running an ILNP modified Linux kernel, and but running over these commercial routers. And we had some discussions on fixing a possible issue with DNS, additional information processing, and that was actually fixed. So that was a good outcome. I spoke to Stefan Bortsmeyer, and after I uploaded these slides, I should also thank, so I didn't put his name in, but Peter Spatchik actually did the coding to put this fix into one of the DNS servers. So thank you for that as well. This is the demo that we had running. We had it's not very easy to see, but you've got two boxes at the, what is your right-hand edge running the ILNP code, and in the middle we've got four little edge router boxes. Those are R1, R2, R3 marked in the logical diagram, and we emulated a mobile node moving across them. So no mobile IP there, just unicast routing. And what happened is that as the mobile node moves across, it's running a TCP flow from the blue node, the correspondent node, while it moves. And we just wanted to see, can ILNP do what it's meant to do, which is to change its location seamlessly as it moves across those different networks. And the results we had showed here on this graph, the individual throughput on the network shown on the top three facets of the graph, and on the bottom graph is just the aggregate throughput you see at the correspondent node. So that was pretty good. We got a consistent TCP flow running across those commercial routers running ILNP end to end. They were just running unicast routing, but we had a mobile node. This was work that was done mainly by my PhD student who's working with me at the, that's saying my time is up, at the University of St Andrews, and we had some former students who also contributed some code, and just some thanks to some people who have made it possible for me to be here today. Thank you very much.
Okay, I2NSF is next, and TAP is now. TAPS is now.
Hi, I'm Teresa. I'm presenting for the TAPS table, which is for transport services. Just a quick recap what TAPS is. So we are developing a sort of an abstract API for different transport protocols, and those are just the transport protocols our current PyTabs implementation supports. Of course, it will be nice to have Quick in there as well. So the idea is the application specifies some abstract requirements, and then it gets a generic connection, and the application doesn't have to care whether it's like a new transport protocol. This is being worked on by the TAPS working group right now in those three drafts. Now, in our PyTabs implementation, we added a few things here at the hackathon. So we have tests now, and we worked on racing between different transport protocols. So of course, those are not really equivalent, but if we have transport protocols that are sort of provide the same features, then we can try them at the same time and sort of go happy eyeballs on them. And we are working on that right now. Also, we are working on getting multicast to work, which is kind of work in progress. Also, we have a nice, interesting concept called framers. So the idea is you get a byte stream from TCP, but then you have a sort of a delimiter that delimits your byte stream into messages. And this is a concept that has been added to, or that has been expanded in the recent draft. And so we've been discussing framers a lot. And there's also going to be more discussion on this concept in the working group. So we have some feedback because in our implementation, we have implemented it and some parts were unclear. Also, we're going to discuss how much of this we have to specify. From the tests, we could fix some bugs in our implementation, obviously, but also we are sort of modeling the input that we get from the application, and maybe also we're going to model the output, sort of the resulting connection. So let's see where this leads in terms of comparing different implementations. And also we have some other minor additions to the draft. So the people who were there the entire weekend are mostly Jake, Max, and me. Also, we had more discussions with people from the working group, Philip and Tommy, for example. And so thank you to everybody who contributed to that. And this is the link to our repo.
Okay, I2NSF now, and SRv6 VPN Yang next. Okay, left and right button.
Okay. Hello, hello. This is Paul Jung from SKKU in Korea. Let me introduce I2NSF framework hackathon project this time. So, left and right. Oh, left and right. Okay. Okay, you can see. Okay. So this time, I2NSF hackathon project, we want to prove concept. The purpose of our I2NSF framework can work on top of a commercial public cloud platform. It is called the SOA. You can see security on air. So we proved our 3 interfaces on top of this commercial platform, and also we demonstrated the security policy translator works well. So this is a building block, and so this shows the internet draft at I2NSF working group. And this is a poster. So this is our during the weekend we work together, team photo. So this figure shows I2NSF. So this is the nice I2NSF framework project. So you may be familiar with this one. So this time we involved with commercial firewall NSF. So here with firewall, and also we used the previously we used the Suricata open source the web filter. So this time we combined the commercial firewall and open source Suricata for web filter together on top of a commercial public cloud system developed by the ATR in Korea. And so the slide demonstrate a couple of, you can see demonstration here. So the register, the NSF features, and also consumer interface used to deliver the security policy in the high level point of view. And then security controller translate high level policy into low level policy. So this is, you can see one you see is the one you get. So we provide the user interface to easily configure network security functions using this dashboard. Yeah, okay. So we provided 2 scenarios, filtering and web filter. So this time we prove concept I2NSF interfaces working on top of a commercial platform. Also, we show that the translator is working well. So tomorrow hack demo, we can demonstrate. We'll be happy with your visit. Thank you for your listening. Thank you.
Okay, SRv6 VPN Yang, and coming up is LP WAN. Use the left and right. Yeah.
Hi, this is Michael, and I will introduce the hack project of SRv6 VPN configuration using the module. Yes, this is our hack plan, and we know we already deployment SRY6 VPN and configure SRY6 VPN CRI or native SRY6 unit model. And the standard SRY6 model is under development by IETF. So we're looking forward a path to support the operator's controller use IETF YARN model to interact with vendors native YARN and that to deployment on the legacy device. And so the project here is we using the Ansible playbook and IETF unit models to configure SRV6 VPN and implement the key features in IETF SRV6 model. Also, we want to development plugin to support standard YARN model to translate to native model. Sorry. Okay, this is what we got. What we got now. And then we implement 3 Ansible APIs. One for SRV6 Global and SRV6 and SRV6 VPN mode. And we also developed an app to allow the command IETF model to the vendor native YARN model. You can input the IETF SRV6 base model, and the output is a native SRV6 model. And here is the function and the workflow. For the new device, you can directly implement the IETF model, and for the legacy device, you can use a plugin to translate the standard model to the native model. And what we learned is that IETF SRV6 module can deploy to support the SRV6 service delivery, and we use Ansible playbook to orchestrate multiple tests. And here's the problem: is that the vendor legacy device may be only support native YARN module, and the operator or controller may want to deploy the IETF standard module as a common interface to interact with multiple vendors. So we develop an app to address this issue, and it works well. If you like to, if you are interested in this topic, you can join tomorrow's happy hours, and we will show the demo and discuss the detail. Okay, this is our team member. Thanks everyone's contribution. Thank you.
Okay, LP1 is now, and PBT is coming up next. Left and right. Okay, good. Good afternoon. This is a report from the LP1 OpenCheck table down in the back. So at this hackathon, similar to the previous few hackathons, our goal was to improve the open source implementation of Check. Check is a protocol defined at the LP1 working group. It's about compressing headers and providing fragmentation so that IP protocols can be transported over LP1s. And LP1s are low-power wide area networks such as LoRaWAN, Sigfox, NB-IoT, LTE-M, or IEEE 15.4W, which are characterized by very small payloads and very reduced bandwidth and energy resources. The major draft is the first one shown here, and we have a few continuation drafts. So what we got done this weekend was merge several feature branches in our project. We had separate developments over the last few months, and which resulted in basically the compression being in one branch and fragmentation in another branch. And so we merged that so that they're now fully integrated. And we got the basic tests running again, and a few details to be ironed out yet. And one of the branch provides the new fragmentation mode that was introduced last fall, including extensive testing of that. We added a few other functionalities, so simple OAM stuff like ping responses and all that stuff. So that one major achievement, and the other one is making the project easier to use for newcomers. So we created a user guide how you really run the code simply when you get started. We added that into the Sphinx documentation of the project, and we also wrote a test plan to do random testing of the fragmentation machine. Whoops. So yeah, what we learned is that it's easy to diverge on such projects when you have contributors overseas that you quite don't know beforehand. We also want, we really want to lower the adoption barrier to this project so that newcomers can get used to it without draining too much of the resources of the old timers. And also, yeah, we want to provide complete examples, and we want to become the reference implementation for Czech. And that's our team, 10 members, one new hackathon member, 3 people remote from Japan, Spain, and Chile, which allowed us to run 24/7 over this weekend by having the Japanese guy working while we were sleeping. That's it. Thank you. Okay, PBT is coming up, and the next one after that is IP Wave. Okay, we have a PPT. Let's see how well that works. Click on present. Yes, of course. Okay. Yeah, I can't. I'm not able to advance it. Okay. So we've asked PBT to upload a PDF, and we'll come back to it. So for now, IP Wave and Arts2U is after that. Use the left and right.
Okay, thank you. So this is a Paul. So I want to share the experience IP Wave project, basic product protocol project. So the goal is to prove the IP version 6 over L2.11 OCB wave, IEEE wave logical link layer. The second one is a vehicular neighbor discovery with the address restoration and multi-hop DAD. And also we take advantage of intermediate vehicles in Bennett to reduce DAD time. Also we can short the initialization of TCP UDP transmission. So we proved the 2 draft OCB and also vehicular neighbor discovery draft. So this is a poster. This is the portal, the team. So this figure is the vehicular network architecture. So you can see vehicle can communicate each other using V2B, also communicate the V2I. So our idea is you can see the beaker, even though it is not a communication range of load side unit, this is providing internet connectivity to beaker. So it can initiate DAD using intermediate beaker and register using multi-hop DAD. And also once it configured with a global IP address, it can start the TCP UDP connection. So we proved using simulation. This figure shows a sumo for loader simulator. And also we use the OMNet for network simulator. So you can see we using a 3-hop multi-hop DAD to reduce the DAD delay, and also we can start the quickly TCP connection. So this is a protocol stack. The left-hand side is you can see wave protocol stack. This is IP. This is a web sort message protocol for safety. So we implemented for a logical link layer and IP version 6 over L2.11, also neighbor discovery. So the simulation result is our neighbor discovery can reduce the legacy neighbor discovery. So yeah, okay. So we during the weekend we learned the proof concept IP wave, OCB, and vehicle neighbor discovery can work for the multi-vehicular network. So you can take a look at the other material for video clip and also GitHub link. Thank you for your listening. Thank you. Yeah.
Okay, arts to you now, and TLS 13 SSH, come on up for next. Use the left and right.
Left and right. So left forward. Okay. Okay. All right. Okay. Arts to You is a feed of arts and culture listings. We're looking to save the producers of arts events time and help them bypass the intermediaries who have kind of taken over their data. No. Okay. There we go. Okay. So we want to improve the discovery and circulation of the arts events while we're here at IETF, and we want to make the arts more machine readable. So the problem is that the arts sector publishes its information in very fragmented ways, and regrettably, intermediaries have become the authorities of compiled arts data. So what we did here, step one was a lot of preliminary data organization, and step two was we constructed widgets for the users, for public users to indicate their interest. And once the games were made, that helped us log the results and feed different information to the users. So, so the before picture of this, as it is on the website, you see all the arts events that are listed there, where the user has not made any preferences, and then the user plays one of two of the games we created, and then in the end, we have recommended events for the user, and then the user can play the game again, and we can learn more about the user. So for the outcomes, we have begun organizing our system to take into account these user preferences, and there's a lot more discussion, a lot more data needs to be generated before we can implement any of this, and we have some questions going forward, and I'm happy to speak with anyone who wants to know about this project. Okay, thank you very much.
All right, TLS 1.3 and MUD onboarding is after that. And this looks like TLS 1.3 is another PowerPoint. So let me give that another try. They wanted to go at the end. All right. Okay.
Yep. I've also uploaded the PDF.
Okay, so we'll catch you at the end when we catch up on the uploads. So MUD,
No worries.
MUD onboarding is now, and then DHCP v6 after that. Left and right buttons.
Okay, hi everybody. It wasn't just MUD onboarding. We muddled in Anima ACP work on that as well. A couple of different drafts that are going on here. So we have the RFC 8520, and we had a lot of projects running around at that center table there. We had work on a MUD reporter. This is a mechanism by which manufacturers and network administrators can learn whether or not their devices are actually putting out policy recommendations that are useful to those devices, or if there's a misconfiguration. Some work on MUDmaker, which generates the JSON. The guys from Sierra Labs completely redid the code, which was nice because it was in PHP and my PHP, which is really bad. And now it's all in Python. Thank you, guys. There was DPP MUD integration that was going on. There was a verification mechanism that was being developed by the folks at NCCOE. And then we had some grasp work and discovery work going on. Let's see here. What did we plan to solve? actually, we just planned to all get together and figure out what to solve, and that's what we did. So as I mentioned, I think I covered a lot of this ground already. On mud reporting, we got a guy back there, Ranga, who sat there and basically coded the entire time. Got an 80% implementation in terms of what he can report out. And we had a lot of bug fixes going on too, to a bunch of this stuff. The mud manager that Cisco did had a loop in it, and it still has a loop in it, but at least we know where it is and know how to avoid it. And I'll be putting in a patch for that. In fact, I have a patch already. It just needs to get committed. So we had some interoperability testing going on. We had a couple of guys here from CCOM who went and actually implemented mud right on the spot in their devices and tested against a number of mud managers, generated themselves a mud file that was appropriate and tested their access. We can now test their access. Then we had some additional integration going on in terms of filters for east-west versus north-south in terms of the verification code. And yeah, we got a lot of work going on. So we know also we need to fail fast. We have on some of our code, and we have a lot of work to do on the mud reporter. Just a couple of screenshots of some of the stuff that went on here. This is the thing that will generate mud files in terms of the verification. And here you have Darshak and our gentleman from CCOM in terms of bringing their hardware that implemented mud either in DPP or directly using things. And here's the long list of people who actually did a lot of work, and thanks to a bunch of organizations who are supporting them. Thank you.
And it looks like a lot of first timers on this one, so that's great. Yeah. Okay, DHCP v6 PD, and then CoinRG after that.
Okay, so hi. This was a spontaneous project. As you may have known, there's DHCP v6 PD on the Hackathon network, and I got chatting with people. And I put together code for FR routing to capture those packets, pick up the appropriate routes, and install them. That wasn't previously possible. Now it is. And that's it.
And we have a new record for shortest presentation. Thanks. Okay, so CoinRG and MapRG after that. Use the right button to go forward, left to go back.
Okay. Hi, everybody. I'm sorry we didn't use the format. In Quebec, we call that being a distinct society. This is the CoinRG P4 hackathon. And this was our first one, as you can see, because we didn't know about the format. Who are we? We're actually a proposed research group. We're still waiting to be a real one. But we want to look at everything that works, that deals with computing and the network, and investigating this whole continuum of putting computation from the data center all the way to the edge. We want to look at architectures. We want to look at protocols. And we want to look at real-world use cases. And this is the reason that we're having this hackathon, because there's a bunch of people who invented a language. It's called P4, which is currently being used to do some specific programming in switches. And we wanted to look at this idea of this cloud to edge computing continuum in P4. We didn't have a specific project, except our remote participant. Most of us were pretty much new users. And because of that, we have to really give a shout to the company, the Montreal company, who sent us 2 engineers for 2 days to help us setting up our environments and developing the code that actually at the end, we ended up doing real work, which is like, yay. So what we did, and yes, Remy and Pierre-Louis are gone, but hey, thank you guys. We did the basic examples. We had actually one very, very proficient, sadly, a remote participant who actually implemented and started implementing an IPv6 switch machine learning in P4. He checked his code in the GitHub, and it's related to a work that was done before in IPv4. We actually poached people from other tables actually who joined us. We had 12 participants at the end, so that was actually pretty surprising for us. And the people we poached included people who started looking at P4 to Golang. And this morning we did packet filtering and we gathered a ton of information, and I'm always done. And so our next steps, we want to continue gathering projects. We think that, we have a good chance to become a real research group. So we would like to have a coin interim, and we want to have another hackathon in Singapore because we really got the heck of this. And we would like to really, really thank the hackathon organizers and our helpers and our participants. Thank you very much.
Okay, MapRG now, and hackathon measurements is next. Left and right.
Good afternoon, everyone. So the measurement analysis for protocols research group participated in our third hackathon this time, and I'll tell you what we were up to. The problem that we were attacking on at this meeting, during this hackathon rather, was to produce a reference implementation for doing IP address aggregation. Two applications of this are doing address-based anonymization, where you aggregate, say, your IPv4 address to a /24. What do you do with IPv6? Another application of it is, for instance, to find homogeneous populations, for instance, for content delivery networks to do matchmaking between the users and the content. The specific problem to solve was, how do we take something like a Patricia tree? If you use Python or Perl, you know this as NetPatricia, or in Python PyRadix or PyTricia. How do you use a data structure like that to represent all the activity in the entire internet? It's too big when you have tens of billions or hundreds of billions of V6 addresses. So, to solve it, we decided to take an existing code base in C, the Aguri tree, which is an implementation of Patricia tree, and make portions of the tree immutable. And I'll show you why that solves the problem. But basically, it allows you to solve the problem by partitioning it. You can partition the set of addresses arbitrarily into small sets. You can put them on a cluster, and you produce an intermediate result where you can capture the state of the tree as you're performing some operation on it, and then do it iteratively. Well, what were the new ideas, and what did the team agree on? Well, the team, it turns out today, was just me, so we agreed on everything, and we agreed to use the Aguri tree, and we agreed that this partitioning problem could be solved by making portions of the tree immutable. So that's the novel design idea in a Patricia tree. The GitHub upload is pending, and I'll just show you exactly what it was, because we managed to get it done in just a day. So what we got done. So imagine you have a set of active addresses. Here's 10 IPv6/64s, and you can punch them up into one of these trees that are commonly used. It's kind of like a routing table. So we put them in the tree. The leaf nodes are all those active addresses, and then we run some operation, which I call Agurify, which aggregates them in some useful way based on your selection criteria. Like, let's say I only want aggregates that represent at least 32 of those active users. Well, the problem is, if you run it the old way, it'll aggregate up the whole tree because there was nothing there. So the simple idea is, I just bound the tree, or I put in immutable entries and basically make a horizon or a border on the tree here measured in red. And so when I run an operation like an aggregation, it's bounded by that red portion, and we get a result, an intermediate result that I can then do iteratively, like, say, on a MapReduce cluster with hundreds of machines. And then, so to give you an example why this is important, you probably think in IPv4 you know what a /24 is. In IPv6, even with this small data set of 188,000 active /64s, this shows that about half of them reached this sufficient aggregation at /56, but another half of them needed to be aggregated /40. And today in the V6 internet, a lot of people use /48, which is right in the middle, and a horrible compromise, because you could have a better answer, or you're not aggregating enough. So what we learned is that this is a candidate best practice, and we'll carry it to the working group. And I made a couple other design decisions, again, that were unanimous. So it was just me, based on publicly available open source code from some colleagues, including Kenjiro Cho. And we're going to meet on Friday, and I'll go over some more of the results. So join us on Friday at MapRG if you can in the morning. Thanks.
Okay, measurements. Just the 105. Okay, got it. and use the left and right buttons.
The left and right. Okay. So hi, I'm Al Morton, and I led a championed project today on measurement using UDP to measure IP link capacity. And we had Len Chavatone remote and 4 first-timers who all joined the project because we put the asterisk next to the name. Yes, you're welcome. All right, so here's the plan. We have this metric and method of measurement. We have the draft up ready for a 5-minute talk in IPPM Wednesday, I think it is. Our goal here was to gain UDP-based measurement experience with a busy 1 gigabit access at IETF. Everybody knows how busy that can be. And additional access types were made possible by our volunteers that joined. And I just want to mention that, you know, all the names here, Ryan Hoffman from TELUS, and Ryan's going to speak a little bit about his results, and Timothy Carlin, Marion Dillon, and Kyle Ouellette, all from UNH at the Interoperability Lab. Thanks so much for joining this. Okay, so here we go. So we ran the tests, we iterated some measurement parameters. We're going to revise the tool based on what we learned and compare with the commercial tool. Everybody knows what that commercial tool is. It's Ooklas. So we ran from here side by side for the tests that I ran to the UDP server in Middletown, New Jersey, both servers and clients on the same machines. And here's a quick representative set of results. With the UDP speed test, you know, we're seeing the effects of the traffic here. We're only getting into the 800. I mean, it's a gigabit per second access, right? We're getting an 800, 650. Ookla measuring a lot lower. We go back and measure with UDP ST, and now we got a lot closer to the limit of 1 gigabit per second. And then in the afternoon on Saturday, everybody was pounding away here, and we really need to learn the signature of what that is. And my time went away. What the hell? Oh, there it is. Oh my gosh, it's only 46 seconds left. Go.
So I wanted to include non-congested links. So set up a connection between our TELUS lab at Edmonton, Alberta, with Al's New Jersey lab to perform the same kind of test, but in bulk. So I'm using 2 servers here in New Jersey just to be able to get the bulk of tests that we needed. Unfortunately, the server in New Jersey only had a GUI. So this shows the comparative results, a consistent near gig speed result with the UDP speed test, as opposed to the TCP test, which was highly variable. Really important information for us, because it's difficult for a technician that's going into a home selling a service and using that test to reveal to the customer what their achievable speed is and it being subpar.
And the UNH folks walked in this morning, got this test running, and and resolved the problem with their router screening in the firewall on UDP traffic. And made it work properly right after that. It was a great effort in just a few hours here this morning. And we learned a lot of stuff for potential development. And you know, you can learn a lot from testing different access types, that's for sure. Thanks very much.
Okay, so I think that's all we have downloaded. Let me go grab the new ones. Yeah. Okay, which yeah, let me see. 29, did we do DNSSD discovery proxy? What? Yeah. So DNSSD discovery proxy.
Hello, I'll make this really fast. So we're here working on making discovery work with less use on multicast because multicast. We're here making discovery work with less reliance on multicast because multicast is slow, it's unreliable, it's wasteful of shared wireless spectrum. There's a list here of the drafts The discovery proxy is based on the hybrid draft, which uses DNS push notifications, which in turn builds on DNS stateful operations. We've been building code for OpenWRT running on these little GL iNet AR750S little pocket gigabit router. I was here working with Ted, and Barbara joined us. Thank you, Barbara. We did a bunch of work with integration, OpenWRT package management, dealing with asynchronous change notifications with UBus to really polish this code. This is all available on the IETF Hackathon GitHub, and we now have pre-built packages. You can download it yourself and run this, and in about 5 minutes have your own discovery proxy running at home. Thank you.
Okay, WebRTC, and then it looks like PBT is after that.
All right. Hey, my name is Alexandre Goyard, and it's a very difficult name to say, so people call me Dr. Alex. I will represent the team here about WebRTC. WebRTC is a technology to bring real-time communication, audio, video, and data to the web, and it has an IETF pendant, which is RTC web for all the protocols, the encryption, the security, the codec, and so on. The last missing piece is called simulcast, which is the capacity to send different resolution of audio and video simultaneously over the wire to finish the spec at W3C. So some of us came around here today to try to push that so that we can finally have a finalized spec and people can implement product on top of them. We had two browsers represented today, Firefox and Chrome. The two others were excused for visa reason and other things. We had free media server represented to give feedback on the implementation, which is also very important. And finally, free application vendors that were using both browsers and media servers to help communicate about the needed and missing functionalities and different bugs. We had different people going at it at a different angle. Some of us just took some bugs and went through it. But globally, it was a very efficient session. We went through 10 different bugs in different browsers. And we also helped different vendors implement simulcast in their media server, or at least make progress there, and provide feedback to the missing pieces. So all in all, very efficient session. We're very happy, and we made a lot of progress in 2 days that would otherwise not have been possible without the opportunity to have a face-to-face the hackathon gave us. So thanks to the sponsor, and thanks to Charles.
Okay, the PBT. Left and right.
Okay. My name is Lucy. Yeah. Today I will introduce my project, postcard-based telemetry for insider flow information telemetry. At first, I will introduce what is the postcard-based telemetry. As we know, there have already been defined 4 data types in IETF draft IOM data, including 2 type tracing type, one POT and The last is H2H type. Now we will define another new one, tracing type, we call it postcard-based telemetry. So what's the difference between the postcard-based telemetry and the IOM tracing type? At first, we separate the telemetry instruction header and the metadata. So, like this picture show, the red one is the instructor, and the yellow one is the metadata. Postcard will shape the metadata will shape out hop by hop at each node. So the host as a collector will get the postcard metadata. Why? Then I will tell why we introduced this new type. Because we list 3 reasons. The first is use this type, tracing type, we can detect the location of the packet loss. And then we can solve the encapsulation length with the fixed packet header. Sorry, a little nervous. And the last one is different the queue's priority for the metadata from user traffic. And then the IFIT header definition as shown in this diagram, aligned 4-octet aligned. There are a little different from the IOM type, the IOM header. There is no length bit, and there is no metadata. Okay. This page shows this project in Hackathon. At first, there are a network domain include 4 routers, and a tester will send 2 test flows, and also receive these 2 test flows in IPv6 transport as the transport protocol. The router 4 as the ingress node to encapsulate the IFIT header, and the router 3 as the egress node to encapsulate the IFIT header, and router 6 and router 5 as the transit nodes. The yellow one is the metadata. It's collected to the collector. The collector framework is circled by the dashed line. We built the collector framework based on the open source project. For example, the Kafka as distributed message queues, and the Radius as the memory DB, and then the Grafana as the GUI. So we collect all the metadata and program to show the following 3 cases. At first is the delay monitor for each node and link, and the end-to-end. We can see from this black panel, on the right of the black panel, and case 2 is show us the packet loss monitor, just the 5 packets loss, and the last case is the path tracing in the left side. Yeah, that's all. Thank you.
Thank you. So let's read. There's.
We didn't do yours yet. What's the
We have the floors DNS. We're ready for that one, and then it looks like L4S will be after that.
Thank you.
Use the left and right button.
Yep. Okay. Thank you. I will stand like this. Keep it tight. The floor is DNS. So the floor is DNS themes. So the DNS table was a quite eclectic group of people. It's like the DNS protocol probably. So we did something about DNS privacy, DNS support for specific networks, provisioning, and miscellaneous stuff. The catch-all. So the DNS privacy work we worked on was zone transfers of TLS, XOT and XOT. So you want to protect your zone, it's encrypted, etc. XOT is the push model, XOT is a kind of subscription model. Sorry, yeah, it's a subscription model. DO proxy plugin for any web server by Peter. It's a fast CGI plugin interface. And there have been some preparations for DOT and DO in bind. So there's a lot of been discussions on DO in DNS community and besides that. And we think that choice for end users and deployment are important. So I think there's a good work that we include this DO support in different pieces of software. Good. The DNS support for specific networks. So DNS is kind of the Swiss Army of the internet. Of course, I'm working DNS, so I have some specific view on this. But so for IDL and P presented already, there was some collaboration between Stefan and the ILP group to extend part of the implementation of DNS to work with an identifier locator split. And in some other situations in the IPv6 only setting, but you ask for a quad A, there's only a record, there has to be some middle box that has to do some translation. So there's the DNS prefix discovery by Mark implemented in bind. Again, DNS as a provisioning tool here. So if you want to do something with Anycast and you don't want to create a plasma gun for DDoS attacks, you want to have an Anycast open resolver with something like a DNS server cookie. So you protect your open recursor for DDoS attacks with spoof addresses. This is implemented in bind and unbound NSD. Another provisioning thing is temporary records in the DNS. Sometimes like the Let's Encrypt ACM of the ACME protocol, you want to publish some information for a short time in your DNS zone. So you're the owner of a domain name. Get your certificate, you have the timeout resource record. After that, the information is removed from your zone. Another important thing is the HTTP SVC. It's kind of a service record. There has been a long-standing problem to solve, actually. So how do you provision your web service? And how do you address them in the DNS? There have been a number of solutions over the years by the DNS community, by the HTTP community. And this proposal seems to be proposal receives positive feedback from both working groups. So it's a lot of interest here, and there's an implementation in Unbound. The miscellaneous catch all. We did some work on YAML format in DNS packets. The original RFC is actually about JSON. But the original author of the RFC says, well, YAML is fine, it's readable, and it's already in use in the proof of concept of root server measurements framework. That's all. So wrapping up, we did a lot of interop between ourselves, between different groups, the ILP group, the web community. I think we have done some good work. That's all. And these are, yeah.
Thank you. Okay, L4S and then Wishy. left and right.
Thank you. And I want to thank the organizers of the whole thing as well. Thank you very much. Right, low latency, low loss, actually it's low latency, low loss, scalable throughput. Got the name wrong. This is L4S going on in the transport area and TCP/M and TSVWG. Right. A bit of background here, but I'm not going to dwell on it. There's where our code is all linked from and the specs we're working to. Had quite a number of people. We actually expected to have more, nearly all remote and hardly anyone here, but it worked out the other way around. Something like 7 newcomers, which was pretty good. And quite a few projects we didn't expect. I'll jump to the next slide and then I'll come back. We did plan something that didn't happen with a bunch of people remote that were all new. Just it became impractical. It's time in India, basically. And didn't quite get to finishing, but going back, quite a few projects we brought a test bed with us, got that all set up, found there were problems with latest Linux kernel, screwing up what we had intended to do, etc. Had to rebuild things, blah, blah, blah. Richard got on well with Michael Tuxen implementing accurate ECN in FreeBSD, with Michael Tuxen helping. There was also, I suppose, the highlight really was the L4S test bed. We had the SCE people come over and give us their Flint work that they wanted us to evaluate on it. And we started working together on that, which will probably continue during the week. Oh, sorry. And I'll now come on to that. We started the first scenario and we've got the others to do. Also, the NS3 implementation fast start was added. Richard made good progress on the FreeBSD implementation, which didn't exist before this. Got the handshake and the feedback working. Added the protocol to packet drill. And we built a good relationship with the SCE team. That's we, the L4S team, but now we're we, the L4S and SCE teams. What we learned, well, TCP behavior keeps changing in recent Linux kernels, so I think we're going to have to develop some regression tests for the maintainers, because it's just impossible for us to use it at the moment. Or you have to keep going right back to an early version of the kernel. Accurate ECN, we now question one of the most recent change we made to the spec, having tried to implement it, so we may go back on that, but we've got to rethink it. And discovered that a counter that crosses a byte boundary, obviously we knew it crossed a byte boundary, but just made it, started thinking about cross-compiling and stuff, made it a bit more challenging to make sure that would compile correctly. And also learned that remote attendance of newcomers at a hackathon doesn't really work. Yep. Okay, thanks.
Okay, where's the wishy? Here's the wishy. Okay, left and right.
Okay, thank you. So this is a report from the Wishy hacking activity here at the IETF Hackathon. So Wishy, work on IoT semantic and hypermedia interoperability, is a long-running activity. At the IETF, this is already our 6th hackathon. We are in Team Building Research Group, but of course spanning work across multiple organizations and individuals. Usually our plan has been finding different ways to turn on and off lights, because that's what IoT is, of course, all about. This time we had a slightly different focus here. We work on 2 major topics. One is this IoT data model convergence, so reducing fragmentation, increasing interoperability on the data models. And then hypermedia for IoT, but this time instead of focusing on lights, focusing on making coffee. The specifications included, in particular, working on Coral, the constant RESTful application language that has been in the Thinking research group quite some time and now moving to the core working group for standardization, but also specifications from other organizations. So we've been working actively on the one data model simple definition format, and then also data models from other organizations, in particular OMA spec works like with M2M and IPSO models. On the data model convergence, so we use the one data model simple definition format to do data and model interchange. So the format is a language that you can use to describe data models from variety of different organizations. And based on those descriptions, you can do, for example, translators between those models, but also able to exchange model data. So bring, for example, models from different ecosystems to your ecosystem. We have been working on some automated tools for this purpose. So we have this automated conversion of IPSO LiveWithM models into SDF, and we spent some time in the hackathon improving the tooling. And in addition to improvements, we also discovered quite a few potential improvements on the SDF language itself, so on the data type, schema, and constraints. In the SDF language, we'll be using JSON schema for doing the validation of the models, but also after this hackathon, now we have a tool for generating CDDL schemas for the SDF language, and we can use all the CDDL tooling for that too. And as a side result of this activity, now we have also a JSON format proposal for Coral, so you can use the usual JSON tooling with your Coral representations. One activity on the data models was this binary data extraction. So if you have something that is not in easy usable JSON format or such, you can now use these tools for extract JSON LD from it. We have Playground deployment available on that you can post your data and get JSON LD representations back. And the other big one was this proving coffee with hypermedia. So of course, from the days of hypermedia, hypertext coffee pot control protocol times, we've been wanting to do this. Now we have modern tools and protocols for this purpose. So you have a carrier-grade coffee machine reference scenario, also known as Karsten's coffee machine. You can discover and describe your coffee machine, discover menu options, make coffee selections, and finally get some coffee brewed. We have now 2 open source implementations that use Co-op and Coral to achieve, especially the first 3 steps. The last one we're still working on. And this is the set of people who are working in our team this time. We have 1 new first-time member, Mike McCool, and we had 2 remote participants. If you want to see more information, links, open source implementations, etc., you can go to our wiki page, and all the information is there. Thank you.
Sorry.
Okay, I see the quick.
Hi, this is the report from the quick table. We're the big table in the middle somewhere. We are also the HEV3 table because that's kind of the same thing. This is our regular interrupt spreadsheet. It's getting pretty crowded. So we had 19 implementations that we're tracking. Most of them are both client and server. Each letter is a test that's either passed or not passed. We now have 3 lines. The first one is sort of the table stakes, basic protocol stuff. Second row is quote-unquote advanced features that should really be part of the first row, but they're not sufficiently widely deployed yet that we can do that. And the third row is new, which is a bunch of new tests that specifically test HEV3 compatibility. You You see a bunch of white compared to what I showed in previous hackathons. That's because the -22 drafts only dropped like maybe 10 days ago. So a bunch of implementations basically didn't have time to update yet. So this should change. But this is the most implementation we've ever had. We keep adding new ones, so it's looking pretty good. Most of them were here. A bunch of people also sent engineers specifically only to the hackathon, and they're not going to stay around for the IETF, which is kind of an interesting development. So it seems like companies find at least more benefit in hackathon than the actual standards meeting, which we should maybe consider in some form. So I've shown this a lot, so I'm not going to spend much more time on this. One thing that's also new is, I don't know why this shows up like this. So there's Jana Iyengar and Martin Seaman have done a bunch of work. So I don't know, if a bunch of researchers amongst you probably know NS3, which is a network simulator. And Jana and Martin have worked on allowing you to define an NS3 simulation, so you can define well-defined TCP cross-traffic or topologies, and then you can plumb in actual quick implementation into that topology, and you can do congestion control testing, for example, repeatable. So it's kind of nice. It's kind of cool. It's early days. This is the first time we tried this. We plugged in, I think, 2 or 3 different ones. This is a sequence number plot. So the transport people will be very excited because now quick starts to look like TCP. You can look at this graph and you see what's going on, which was hard before because it's all encrypted. So with endpoint cooperation, you can generate plots like this. This is from the simulator with one of the stacks. We're using Robin Marx's tool. There's the logging format that's being defined called QLog. He has tools to visualize QLog into something like this. So on the bottom, you see like how the RTT changes, that quick things it has over the path. And then you see the regular sequence number ACK plot. So this is exciting because finally it means you don't have to be like look at the bits anymore in order to understand what's going on in terms of congestion control. So this is very cool. Thank you.
Okay, if there's anyone other than TLS 1.3 who uploaded a presentation and hasn't presented yet, come up here and see me. And let's go find the TCP 1.3. You saw it? Got it. Or TLS 1.3. I said TCP. Brain check. Okay.
Barry, can you help us with the slides, please?
Happy to. Just say next slide.
Okay, thank you very much. So greeting, it's Logan from Mauritius, from the Cyberstorm team. So we are based in Mauritius. So we've done a bunch of work on TLS 1.3, SSH, SCE, the new DSCP code point, and the IETF mobile app. Next slide, please. So TLS 1.3, our aim was to get more applications running on TLS 1.3. DSCP-LE, it's a new code point that was just became an RFC, and we've been working on integrating that into open source projects. Then there's the IETF mobile app that we started working previous IETF. Then there's the SCE draft that came up recently, and then the last thing that we work on was on deprecating RC4 in SSH. So next slide, please. So TLS 1.3, we've worked mostly with Golang-based software packages. So Mattermost, it's a Slack alternative. So the PR was sent. CheckSMTP is another Golang package that's still work in progress. And MINIO, which is for Amazon S3, still written in Golang. We've added the TLS 1.3 support. And lastly, we've got TLS 1.3 API integrated into PHP 7.4. And the last thing is that we are developing a C# library for TLS 1.3 called TLS Sharp. And it got refactored, and it has some support for hello retry and things like that for TLS 1.3 in C#. So the other stuff that we've been working on is DSCP-LE. The new code point, we integrated the patch, we integrated it into NetPerf. The PR was sent to OpenSSH, and it was also sent to NFTables. The other thing that we worked on was the mobile app, as I said. There are links to the screenshot, and it has improved compared to last IETF. There's a C# implementation of SSH that's still running with Arc4, and we've deprecated that. Lastly, we work on an SE implementation for FQCodel in FreeBSD based on the draft that Rodney and Jonathan were published. It's still very basic, but it's enough that we can see SC packets on the wire, on Wireshark. So next slide, please. So what we learned basically was open source projects tend to want to wait for new DSCP code points to become RFC before accepting patches. That's the case for SSH, so we wanted to wait. RC4 in SSH is mostly fading away. It's mostly going away. We've not seen that many cases of open source projects still shipping with it. SC is just starting, so it's worth looking more into that. There's also other work that is going on with other SC developers. And lastly, Golang 1.12 ships with TLS 1.3 API, so expect more TLS 1.3 in software packages written in Golang. So last slide. So that's basically us. We are a whole team here from Mauritius. We are grateful to our sponsor, Business Kiosk Venue, who hosted us. And those are the links as well to our repos, where we have some of our results. So for the SC, as well as the code, and for the IETF mobile app, we have it there over that link. And we also included the link for the TLS Sharp library. So thank you for everybody for listening to what we've done.
Thank you, and it's interesting to see an entire project remote. That's cool.
Thank you.
Anybody we missed? Okay. Thank you everybody for presenting, and thank you everybody for coming to the hackathon. And Charles is back up.
And thank you so much, Barry, for helping with the presentations. It's a lot to go through, and it's handy to have help, have a couple people. We're always welcome more help for the hackathon. We also huge thanks to our sponsors, to ICANN. They really stepped up big, as I mentioned, not only for this hackathon but for the next two. We'd really love to line up more sponsors for the hackathon because, as you can see, it's quite large, and it takes a lot of money to feed us and to have a space for us. And great to see that everyone gets so much value out of it. So if you're at a company or an organization that has the ability to sponsor, we'd appreciate that. And thanks to NovaFlow for helping out this time around. That was great as well. And thanks to all you, really, the champions. Al, I thank you for having your project welcoming newcomers. We want to continue to make this a great experience for newcomers too, not just for those of us who have been working on the standards for a long time. So appreciate those of you who did have new people in your team and you helped them get started. That's just fantastic. So, and thanks for you just paying attention to all the presentations. They were recorded. We'll have them. They were live streamed also. So if you missed something, you can go and get it afterwards. Lastly, if you have, you didn't present anything, but you still have some useful results to share, please do upload your presentation to the GitHub org, or if you want to, you can just send it to me. I'll upload it for you. If you want to put your PowerPoint presentation there or some other format, that's fine now. Just for up here, we wanted the PDFs. And I think that's it. Thanks. Good luck with the rest of the IETF meeting.
And as always, thanks so much to Charles for all the work he does. It's a big job.